Hello, ladies and gentlemen. Welcome back to Math 30-2, Chapter 5, Sections 1 and 2, Characteristics of Graphs. Now, first part we looked at some straightforward graphs. Now we're getting a little bit weird. So, here, x-intercept, y-intercept, mean, and range. With this graph, it crosses the x-axis at x equals 0 or 0, 0. So the y-intercept is also 0. Now the domain, this is one of those graphs I want you to. If you look closely, you realize that is an arrowhead going up and down. So as it goes up and down, it's curving out. So eventually, it will hit every value for x. And the sneaky shortcut, lazy way of saying that is x is all here. And look at the range. Sorry, stop there for a moment. It's kind of important. I should emphasize that. Now, as you look at this, you realize it's going up and down. It's eventually going to hit your y value, or your possible y values. So the range is y is all real. Now, here's another one of these Newton twisted graphs. Emphasize that's an arrow. Up, down, and up again. So x-intercept, y-intercept, mean, range. Well, that's roughly minus 3 and 0. Close enough in calling it that. Minus 1 and 0. And 2 and 0. It has 3 x-intercepts. It still only has 1 y-intercept. Now, note the y-axis goes 5, minus 5, minus 10. So that's, I'm going to call it minus 6-ish. You're right, not the best graph. You know what I mean? Now, notice the graph is going up and down. As it goes up or as it goes down, it's curving out. As it goes up, it is curving out again. So x will be all real. And range, y will be all real. Right? So far so goodish? Good. Now, here I want to point out, at this time we'll deal with these 3 types of graphs. And there's 3 types here. Now the first one is linear, or line. Form is y equals ax plus b. Now that's what's written on your calculator. In grade 10 or grade 11 you would learn y equals mx plus b. Same thing. Slope, y-intercept. Now, here a can't equal 0. That's the only picky thing. The technical term for these are first degree. That is x to the 1 power. They usually have 1 x-intercept. Usually have 1 x-intercept. Domain, x is all real, range, y is all real. And note the fancy way of writing that with set notation that I don't bother doing because I'm lazy. Right, so you have to know that. So quadratic, y equals ax squared plus bx plus c, where a can't equal 0. This is second degree because this is x squared. It'll have 0, 1, or 2 x-intercepts. Now, not a big deal, but I want you to realize if I have a quadratic like this, I have 0 x-intercepts. If I have a quadratic like this, just touching the x-axis, I have 1 x-intercept. But if I have a quadratic like that, you can touch the x-axis twice. Now, note that that's a picky little thing you'll see in the diploma. Now, the domain, x is all real. Now, the range is more, is more than a minimum. So it opens up as a minimum. It opens down as a maximum. Okay? And finally, the third type we want to talk about is a cubic. The form is ax cubed plus bx squared plus cx plus d. big thing is this third degree, something x cubed. Okay? 1, 2, or 3 x-intercepts, domain and range, all real. And of course, I'll prove that to you. There's cubic with 1 x-intercept, 2 x-intercepts, put something like this. And I want 3 x-intercepts. There we go, something like that. 1, 2, 3 x-intercepts. The name is all real. That's a fancy way of writing it out. Do I care? No. Now, I'm going to pause recording. I want you guys to go back to the previous graphs, diagrams, and determine the type graph. Now I'll start helping you. Go right back. Linear. It's a straight line. No, no. Yes, this is linear. Anything else is linear back here. As I said, I'm going to pause recording. You do linear, and I want you to do quadratic. Remember, quadratic is a smile or happy face or frown, and cubic are these twisty ones. So let's pause the recording. You go back and label them all, please. All right. Welcome back. I hope you notice these are all linear. Straight line. Both of these are linear. You have a linear and quadratic. 3 quadratics. Okay, next page. And 2 cubics. All right, that's what you need to be able to do. That's the big thing. Now, some little things. Yes, of course. So, first little leading thing is the leading coefficient. That's the number in front of the greatest degree in the variable. So, what's the leading coefficient here? Well, we go to this first example, the purple one. 3x squared minus 4x plus 5. What's the highest power of x? X squared. So that's the greatest degree. So the leading coefficient is 3. Okay. Now, I want you guys to look at the other two and tell me what the leading coefficients are. All right? Pause recording and come back and compare. Okay. Now the red one, 2x squared plus 1x cubed minus 4. The x cubed is the biggest value of x, or the biggest degree. So there's a 1 in front of it. We're just too lazy to write it out. So the leading coefficient for the red is 1. And the blue one, 1/2 x minus 6. Well, that's x to the 1 power. There's only one x value. So the coefficient is 1/2. Now, the leading coefficient tells us the following for the type of graph. Right? If it's a linear graph and a positive number, it's up to the right. The negative is up to the left. So, this goes back to the good old days of programming calculators. If I gave you, 1/2 x minus 6, what can you say about that? Well, it's plus 1/2, which means whatever else we know about this graph, it's positive, so it's up to the right, so it's going up like that somehow. Okay? Now, if I gave you y equals minus 3x plus 1, that's a negative number, so it's going up to the left like this. This will be minus 3x plus 1, like that. So I can look at the graph and go, oh, I can tell a lot about it, even if I don't know the equation. Or if I don't have the graph, I know what the graph will look like. As I said before, graphing calculators is really important. Now, quadratic, positive, opens upward. So it's plus x squared. It's going to be a smiley face. Negative means it opens downward. So this is going to be minus x squared here. It'll be a frowny face like that. That's something I expect you to know. Now, cubic, positive, rises to the right. Negative rises to the left. So say this is 3x cubed plus whatever. This rises to the right, means up here on the right, and it's going down on the left, and somewhere in between there's a couple of lumpy bumps. Do I know where? No. Now, on the other hand, if it's negative, say negative 2x cubed, it rises to the left. That means over here on the left it's going up, which means on the right it's going down, so somewhere in between we've got a couple of lumpy bumps. It's going to look like that. Alright? Well, that's something I need you to know and memorize. Alright? Now, I'm going to pause here, and then we're going to go on and talk about the last little bit constant. But make certain you've got this, the leading coefficient, what it tells you, positive versus negative, and the basic shape of the graph. Alright?